Hello, your next 7 Caillou challenge is called Predict Your Age. My grandfather always predicted how old people would get, and right before he passed away, he revealed his secret. In honor of my grandfather's memory, we will write a function using his formula. These are the steps. Take a list of ages when each of your great-grandparents died. Multiply each number by itself, in other words, square that value. Add them all together. Take the square root of the result and divide by 2. So they give us an example down here with a bunch of great-grandparent ages, 65, etc. And they note that if you perform the steps above, it should come out as 86. Note the result should be rounded down to the nearest integer. We can see in the method signature that it is expecting an int, so we'll be sure to do that. And then there's a warning for JavaScript. That's okay, we're not playing around with JavaScript. We don't need to worry about that. So anyways, you've got this. Go ahead and pause the video, crank it out, and come on back. So I'll go ahead and get into it. One thing that is just awful about this problem is that they're passing, 8 integers, 8 different arguments. Why not just put them in a list or some kind of an array or in a collection? So really bad design there, but let's work around that. We'll create our own collection, and then we can run a bunch of our typical methods that we've hopefully are becoming comfortable with on that. So I'm going to use a list to store the ages. What do we need? Which library? Do you remember? System collections generic, and we're going to use some link methods to do that summing and squaring of values. We'll get some more practice with that. So we're going to bring in link. First things first, let's make that list. It'll be a list of integers. I'll call mine ages. We're going to make a new list of int, and I'm going to use the curly braces to pass an initializer list. And I'm just going to write out age 1, age 2, age 3, age 4, age 5, etc. because the original designer wasn't nice enough to pass these as a list. Making more work for us. Okay, so good, we have the ages. Now, if you want to look at the instructions, they're really nice here in that they sort of tell you step by step what to do. In real life, it's just going to be written out as a typical paragraph. You're going to get some description from somebody, maybe verbally, of what they want, and they won't always spell it out by the numbers. But since this is a 7 Caillou series, I like how they do that, and we can just start implementing these and just building it from each step at a time. So let's start with bullet 1. Take a list of ages when each of your grandparents died. We did that. We made ages, right? Good. Number 2, multiply each number by itself. How can you use link? I know you can do this. You've seen me do this a bunch now. Ages, but we like repetition here, right? That's how you learn. And we use select because it projects each element into a new form. We'll still be using integers, but now we want a square of ages. How would you do that? Well, I'm going to use age for my parameter name. We don't need to enclose it in parentheses because it's a single parameter. And then what do you do with it? Age times age, right? That's how you square it. Or you could use math pow if you wanted to use that. I'm just going to say age times age to square it. Okay, multiply each number by itself. Bullet 2, check. Number 3, add them all together. Do you remember how to do that? So at this point, we know we have a list of squares, technically an IEnumerable of int of squares, but I'll just speak casually. We have this collection of ages squared, and you've got some that can just sum that all up. Easy, bullet 3's done. Number 4, take the square root of the result. So, do you remember? Math has a square root method that we can use for that. Good. Because sum should have just returned us some integer, right? And then we'll math square root, and then divide by 2, right? So we have our square root, simply divide by 2. Square root should return a double. Feel free to consult the docs if you want to check me on that. And then finally, we have this bit about rounding down to the nearest integer, round down. So I'm going to leverage another math function that we've used called math floor. And it just always, think of it as always rounding down. So even if you have 5.999999, it's going to go down to 5. Doesn't matter if it's 5.1 or 5.999. It's all going down to 5. And that's what we want here. So I'm going to wrap this whole thing up in floor. I think I can return that. But if you are looking at square root, make sure you check out floor's document, and you should see that it also returns a double. And we know we're not fulfilling our contract if we return a double. So let's cast this to an integer value. Okay. And you could use convert to int32 method as well if you don't like that C style cast. That should work as well. I'm going to try running with this. Let's see what we get. Green. We'll hit the gauntlet. And there you go. We're clear for submission. So yeah, they made it friendly here, how they broke it out in steps. And as you advance, you'll learn how to take a large paragraph of text or a technical document or something somebody says and organize your thoughts into all these small jobs. That's what computers do. We break big problems down into a whole bunch of tiny problems, and the tiny problems are easy to solve, and you sort of aggregate the results of all of that. That's programming in a nutshell. So yeah, let me know what you came up with. I'll go ahead and submit. I think it should be good to do like this. Get our points, right? Square root, there you go. You got some other good answers in here you can scroll through and look at. Looks pretty similar to what we did. But yeah, feel free to hit me up with those questions, comments, concerns. Otherwise, I appreciate you watching, and I'll see you in another challenge. Thanks.